Welcome to my YouTube channel. Today we'll be discussing probability, but we'll focus our attention on multiplication law. If you have been following this series, in our last class we've been able to treat addition law of probability. So if you have not seen that video, kindly check it out. It's going to help you a lot. We've been able to establish the fact that when you are dealing with probability, events occurs in three forms. It's either they are certain, your result will be 1. If they are not certain, your result will be 0. But if they are in between, your result will have different forms of fraction. And it is worthy to know that in probability, your result can never be more than 1. So, in this class, we'll be treating multiplication law of probability. As you can see on the screen, this is recognized by the word and. And when you say and in probability, they are asking you to multiply. When you say and in probability, they are asking you to do what? To multiply. So this is recognized by the word and. Joining the probabilities. If PA is the probability of event A happening and PB is the probability of event B happening, the probability of event A and event B happening is given by PA times PB. That means whenever you see and in probability, they are asking you to multiply. Similarly, the probability of event A and event B and event C and so on and so forth to event N happening is given by PA times PB times PC times and so on to Pn. So whenever you see and in probability, they are asking you to do what? To multiply. So we have some questions here. Let's tackle them and see how we can work our way around it. As we journey through the video, you will understand better. We have two questions here. Question number 1. Calculate the probabilities of selecting at random A, the winning horse in a race in which 7 horses are running. B, the winning horses in both first and second races if there are 8 horses in each race. Then question number 2. In a batch of 45 oranges, there are 10 bad oranges. If one orange is drawn at random, find the probability of it being A, bad, B, good, C, bad and good. So let's see how we can work our way around. So let's say solution number 1. Solution 1. Beautiful. Now, the question is telling us that we should calculate the probability of selecting at random the winning horse in a race in which 7 horses are running. So, this is quite easy and straightforward since only one of those horses is going to emerge the winner at the end of the day. Because 7 horses are running, there's only one that will win. So solution A, solution number 1. For the A, we have to calculate the probability of selecting at random the winning horse in a race in which 7 horses are running. This question, we've been told the total number of horses that are running. So since only one of the 7 horses can win, okay, let's put it down for record purpose. Since only one of the 7 horses can win, the probability of selecting at random probability of selecting at random the winning horse will give us what? Now, since only one horse, so it's just for us to say number of winners is only one horse that will win over the total number of horses, because we are sure there is only one horse that will win. So let's get the template. So since we are sure there is only one horse that will win, so we just the number of winners. But the total number of horses. Beautiful. So with this, how many winners are we going to have? Only one. And how many horses do we have? The question has stated clearly for us that we have how many horses? 7 horses. So the question is asking us that we should calculate the probability of selecting at random the winning horse in a race in which 7 horses are running. So since 7 horses are running, that's the total number of horses, and it's only one horse that will win. So we have 1/7. So that's for A. Okay, let's put it here. That's for A. Now for B, the winning horses in both first and second races, if there are 8 horses in each race. That means this second question, this number 1B is asking us, we have 2 races. Now we have to look for the probability of the winning horses in both first and second races. This time around we have 8 horses that are running. So this time around for B, now the winning horses in both first and second races, if there are 8 horses in each race. So the probability of selecting the winning horse in the first race, now 8 horses this time around, at the same time, is only one horse that will win. So the probability of selecting the winning horse in the first race, now it means since we are going to have just one winner, and we know that the total number of horses that are running, they are 8. So let's use this template that we have here. This time around, 8 horses. The probability of selecting the winning horse in the first race. Don't forget, the question is asking us for this solution 1, the number of horses in both first and second races if we now have 8 horses. So for the first race now, we have just one winner, That means 1/8. That is clear. Now for the second raise, let me see. The question: calculate the probability of selecting at random the winning horses in both first and second races. That means we're going to get, we've gotten for the first race. Let's get for the second race. For the second race, number of winners, number of horses. Beautiful. Now, to answer the question in this B, they said we should calculate the probability of selecting at random the winning horses in both the first and the second race. Now, we've been able to get the first race, we've been able to get the second race. So, we now say, therefore, for first and second races, for first race is 1/8, then for the second race is also 1/8. By implication, we are multiplying both. Don't forget, we say in probability, once you are given and you are to what? Multiply. So 1 times 1 up here is 1. 8 times 8 will give us what? 64. Beautiful. So that answered the question. So let's quickly move straight to question number 2. In a batch of 45 oranges, there are 10 bad oranges. If one orange is thrown at random, find the probability of it being bad, and good. So let's say solution number 2. Solution 2. Let's bring out our parameters. We're told that the total oranges, how many are they? Total oranges, we have, I think, 45 of them. Let's check. 45. Then 10 are bad. Total oranges 45. So we now have bad oranges. So we say bad oranges. We're told that we have bad oranges. How many of them? We have 10. We have 10 of them. By implication, if the total oranges are 45, 10 are bad, that means those that will be good will be like 45 minus 10. That will give us 35. Though we are not given, but it is just common sense that if you have total oranges to be 45, 10 are bad, then 35 will be definitely good. So to answer our questions now, beautiful. So the first question said we should do what? We should find the probability of it being bad. probability of it being bad. So the probability of it being bad equal bad oranges over total number of oranges. Since we are dealing with bad, let's use this as a template. Since we are dealing with bad, awesome, beautiful. So the probability of it being bad will be bad oranges over total oranges. So how many bad orange do we have? We have just 10 of them. And how many good orange do we have? How many total orange? Total oranges, we have 45 of them. But bad oranges, we have how many of them? Just 10. Awesome. So we can give an answer like this, but mere looking at it, they can cut. We don't leave it like that, we just cut them out. Beautiful. So what number can cut them? Very easy. 5 can go up, 5 can go down. So let's make use of 5. That's if 5 can cut here, 2 times 5 can cut here, 9 times 2. We'll be left with what? 2 here and 9 here. So they cannot cut again. So that's our answer. So the probability of it being bad will be 2 by 9. The second question says the probability of it being good. The probability of it being good. So let's make use of this as a template to ease our job. The probability of it being good. Let's awesome. The probability of it being good will now be good oranges over total oranges. So good oranges, how many oranges do we have that are good? We have 35 of them. Total oranges, we have 45 of them. So these ones can cut as well. 5 can go here, that's 7 times. 5 can go here, that's 9 times. Awesome. So here we have 7 over 9. We cannot cut again. Awesome. That's for B. Now for C, the question is asking us for C, bad and good. If you are saying bad, it means, if you are saying and, it means multiply. Bad and good. Bad and good. So let's see. For C, probability of it C, probability of it being bad and good. Now be what? The probability of it being bad will be what? This is it, 2/9. And don't forget, and is what? Multiplication. And the probability of it being good is what we have the 7/9. Beautiful. So if they can cut, you cut. If they cannot, you say 2 times 7 will give you what? 14. And 9 times 9 at the denominator will give you what? 81. Can they cut 14 and 81? No, so you leave the answer like this. You can always pause, rewind this video for better clarification and understanding. Don't forget to drop a comment with us if you have any issue with any of our video. Kindly help like this video and subscribe to this YouTube channel, My Simple Maths. You can help us to press the notification bell so that you can always receive notification from us whenever we post a new video. Thank you.